We're going to start this webinar with the program. So the presentation, the structure of the presentation will be a quick presentation of the software SCIA Engineer and IDEA StatiCa. I will go through some of the main features of both software, and then we will have a look, let's say, really quick to the skill check and composite design in SCIA Engineer, and then the interoperability with IDEA StatiCa still, and connection and a design of a connection chosen from the first model. Then we will go instead through the concrete part. So we will have a quick look also to the concrete check in SCIA Engineer for the new user that are listening, and eventually then we will have a look to the interoperability with IDEA StatiCa concrete and with the design of a beam of variable height with variable height. This is a little bit an overview of some of the projects, and then you can start with the engineer. A quick focus on both software for everyone who doesn't know them. I will really go through the slides really quick. The webinar is recorded, so eventually you can always come back or you can ask for the presentation. There's no problem. You can have in SCIA Engineer, in fact, any kind of material section type of structure. So you can use it for either bridges or multi-story buildings, or eventually industrial building. There's is really multi-material. There's also a code check for most of the material implemented, so steel, concrete, timber, aluminium, eventually glass or fiber concrete out of the one mentioned before. Eventually you can still implement your own material to then study your project with FEM analysis instead. So we cover lots of course section either from the library, or you can implement yourself on the port from DXF DWG. And as I said before, the FEM analysis is done on linear and on 1D and 2D elements, and eventually other than that, there's no linear calculation, stability analysis, eventually dynamic analysis. You have different type of calculations that you can perform, and as I said, it will cover for the material I mentioned before, either the Eurocodes with the national annex you see on the screen, and then other international code or eventually Swiss code. This was a really quick presentation of SCIA about IDEA StatiCa. The concept is in fact to perform the analysis on either on steel and on concrete for really complex design. So the one which takes most of the time nowadays, because we don't have the mean to perform this calculation. Now we have a solution. So about the steel code check, you can see some of the checks you can perform. So either stress strain, buckling analysis, calculation of the stiffness, and other here below. While IDEA StatiCa focuses on steel connection, IDEA StatiCa concrete instead focus on the calculation and the design of some non-standard beam. So this is a case we will see a little bit today. It's still a quick presentation. There are webinars, let's say, everywhere, or in fact, we can then give you some information about both software. There's no problem. And here you can find then some of the analysis you can perform, check ULS, SLS. So that was really quick introduction, and we pass to something more practical, more live. We will start from SCIA Engineer. Here you can see a structure is quite classical, but then is let's say a mixed structure. We have either concrete and steel and composite here. So we can find different kind of materials and of design for this type of structure. For what it concerns the export and the interoperability, we will dimension one of these connection of the steel structure, and we will export one of these variable beam to IDEA StatiCa concrete for a detailed check. Starting a little bit from the structure, what I say is we just implement a concrete and steel structure. About loading, you can find a lot of information here. So we have permanent, we have live loads, and eventually wind load calculated automatically. For some of the shape, in effect, we can ask to perform a 3D wind calculation, and you can find the result in here. Other than that, combination are generated automatically. In this case, as we implemented a composite design, we have also the implementation, the automatic implementation of the construction phase and on the final phase. I obviously forget to change. I will open it again to change it in English. So obviously you won't be able to understand me. Here we go. You can still see the presentation, so that's good. And I'll start from this. Okay, so coming back to the structure, here we go. So everything I said before is still valid. Here you have the combination for the construction stage and the combination for the final stage. The load case for the self weight of the concrete, either fresh or either dry, is taken automatically and is considered automatically in the combination. So once you implement it in your model, then these two different load cases are implemented automatically. I need to run a calculation. So then we can have a look to the result. We will focus first on the steel check and composite check. So at this moment, what I did was creating a structure that is not completely dimensioned, so we can go through the design of the steel part, and then we will focus on the concrete detailing as well. So I won't go through the result too much. So just to show you what we will have a look at, we will focus then on the concrete for the internal result. A quick overview of the result you can have is, in fact, for example, internal forces on your elements. I just select all of them. So this is a quick overview of how you can, in fact, see and check your result in the different elements. Or eventually, for example, something that could be interesting is deformation. For example, for my purlins. So I'll select just them. Here you go. So in here you can have uh, um, uh, an implementation of the total deformation, but also you can ask for relative deformation. For example, I just pick one of the elements. You have the possibility to ask for relative deformation. You will have a look and you will go through the total deformation to understand where are our support. So actually, then my total deformation will be a lot less. Let me check for SLS calculation. And as you can see, then you can perform it. Here I need to change the parameter so I can show you. So here you can ask about the deflection. There you go. Here you go, this element. So actually, what we are actually saying is the point of support. So where the zero is to in effect check my deformation. Once I save these parameters, then it will take in account in fact that these are my support, my point of support, and the relative deformation will be calculated based on that. So that's the difference between the total deformation and actually our relative deformation that we will use for the LS check. Sorry for that. It's quite difficult to pronounce. So this is about the results. I really go through quickly, and this is for the steel check. So you have an overall check you can perform on all the elements. I'll go through, for example, either all the sections. So at this moment, my elements are not all of them are correctly dimensioned, and eventually you can go deeper in the analysis of this kind of element. For example, either with a quick overview. So I'll go either with a quick overview in which you'll have just the result of the checks. So it's actually saying that there's a big problem in the stress strain check of the element, so probably in compression or moment check of my element, and eventually you can ask, in fact, more in detail where the problem is and go through it. So actually here I can go deeper in my calculation and eventually have a really detailed output where I can actually check my element and design it correctly. So I can go through the section check, as it's called, so compression, tension, moment check on the different elements. All the reference to the code I choose, in this case, Eurocode, is reported here on the right and at the beginning of the table. And then you can go through, in that case, to all the calculation, critical moment, and in fact, all the different parameters for mainly for the stability check that is, let's say, quite complex then to understand and to analyze by hand. So this is a little bit an overview of the different type of output you can have, and you can actually this is the same type of output you will have in the engineering report. And in any case, you can have also an auto design based by section. So for example, if I want to check just an auto design my column, I can go through this auto design and then ask to search for an optimal solution. I can ask then I can choose and pick this column, or eventually other type of element if I want to choose another type of section, or in any case also go to a bigger section and have an overview of the maximum check I have on this element. Once I click OK, the element will be substituted in the model. So then I need to rerun the calculation to then ask for my result. Let's say I have already done this for for this project. So I'll go directly through my project, let's say after auto design. So as I wrote here is actually that. And we will have a look then to also the composite check. So in this case, I rerun all my elements. I can, in effect, go through the still check. I need to rerun my calculation as well. So to take a little bit of time. Eventually, what I did as well in this project, so I can explain you, is also to ask for all the bracing to work just in tension. So nonlinearity has been added, and nonlinear combination as well in this project. So actually, is something then you can check either, and you can have a look here. So there's a little step, and that step is in fact when the bracing are taken into account as working in tension only. So then the stiffness is calculated of the structure, and the efforts then are implemented step by step. In this case, so then we have our result, either linear or nonlinear, and so I can run, for example, as well a nonlinear check. In this case, I can choose all the elements and also the bracing that maybe in a linear calculation obviously won't be verified as they work as well in compression. And here you can actually have a look to the overall check of all my elements. Everything is fine, and I can go through then to my composite design. In this case, I show you also the composite elements. So I show all my models in here, and my composite elements are all this one. So if I show them a little bit more in detail, you'll have all these elements with that are treated in effect as ribs, plate ribs, and we can go through this calculation. So you'll have either a calculation based on neurocode, but also you can perform fire check on this kind of elements. There's class of results, so an envelope of all my results for the composite design, either in the construction phase or in the final phase. And I can show, for example, for the current elements, then my results. So it will perform the analysis on this element. I can have a look then to if there is any issue on this element, and go through the standard. To the standard check. Checker as well, either brief, standard, or detailed. I think the standard, it will show you a little bit a good output of the type of calculation done, either ULS or SLS for the construction stage and for the final stage. So here I'll have for example, my calculation of the element. Eventually, for the SLS check, also the frequencies are calculated. So this is a little bit an overview of the type of calculation and type of control and the output you can have, and and there that you can implement in your engineering report. And we will focus now on the interoperability with IDEA StatiCa steel. So we'll start from the steel check. In this case, what I did was I'm going to pick a node. Is already prepared, so I will focus on this one. I need to ask for the joint input, so that's quite easy. I just need to select it. Once I select it, then it will show all the elements connected to this element, and I can go through the check. In this case, I can export either all the combination. So in this case, I can go through combination, nonlinear combination, or all the classes. Or, for example, in the result menu, what I did was to check the design the design combination, linear combination or non-linear combination in this case for this element. So for example, the bracing is working in tension only, and this allows me then to export it to the StatiCa connection. So I'll do it, and have, for example, my design combination exported. What we will export is the analytical model of this element, so the node with those elements defined, and also it will recognize all the sections and the here you go, and the direction and orientation of all the elements. So as you can see, all the orientation, if I have, for example, a certain angle in my elements, it will be recognized, and all the efforts are exported. As we said before, here is working only in tension, for example. So I won't have, I have a non-linear calculation as well that I can export to either StatiCa connection. In this case, I can pick a little bit the most dangerous one. So I'll take, for example, the first one. And just to perform the analysis on this one, I could do it on all of them, but time-wise, let's see just one. In IDEA StatiCa, you have a lot of operations you can implement. We will have a look at a couple of them in here to then implement your connection, or you have a series of templates. A new version is coming out, and in that case, you will have a lot more of these templates as well. So it will be even easier to implement it. At the moment, I will choose the first one. I just need to ask for the bolts as well. This one is in English, so in French, sorry. So I need to do the same thing. But as you can see, the connection has been saved. So eventually I can show you that then everything you have done will be saved and you can export it again. So hopefully I saved it, and it will be recognized immediately. Here we go. Let's see if it's better. Design check report material. So that's a lot better. And as you can see, as recognized, so every modification you do to the project in SCIA Engineer will be recognized here. Even more interesting is if you, for example, associate the plate to the shape of the element, then, for example, if in SCIA Engineer, I'll change the type of section to IP 300 or 400, etc. The shape also of the plate will follow. So everything we set in here is related to the profile, so it will follow them as well. Also, if you then let's say I have this connection, I can save it as a model and I can use it in another project, even with different type of elements. It will be as well, let's say, updated. In this case, I have this first element I've set. We will have a look to the classical operation instead for the other element. In this case, I'll start from another end plate. I'll add it to B77, and eventually you can use if you want it symmetrical on the other side, as we have this other element on the other side, you can relate it also to that element. So I have my two elements in here, and I want to connect them to my concrete to my column. Sorry. Then, as I said, two profiles symmetrical allow you to, in fact, give a certain shape of the connection. So you can see I can actually shape it based on that, and then I can apply my my bolts. Eventually, I can pick up another little one. Okay, so the diameter will be a little bit better, and And then I need to in fact, attach my gasket. There's an operation to do that. And in this case, I can select my element. I can connect it then to the E77, and eventually I can select my plate I just created. As you can see here, I have my new element, and I can then start to model it. So what I can do is, for example, 300. That's already okay, and eventually I can just add a chamfer. It's like that to my element, or probably it's better this one. So I'll have a look. Here you go. So actually, then I can set 150 and 100 maybe. Here you go. So actually, I can add my elements in here. As you can see, for example, my stiffener in here is obviously interfering from my element. The first thing I do anyway is to run a calculation without them, so we can actually have a look to the results and also to the importance of the stiffener. I'll go then through the check. So it's as well a quick presentation. So as I said, eventually we can give you then all the information on those software. Every question you'll ask, I see there are some already, will be answered at the end for what I can do, and then eventually we will come back to you by email. In any case, as I said, this is recorded, and all the attendees will then be contacted as well from us. So either for to answer some question, or either if you need any other information about the products. So my calculation has been run almost, and we can go through then the stress strain check. So this is what I performed at the moment, and as well the backlink check for that I can perform in the same type of calculation. Eventually, you have then here the stiffness check, capacity design, or design resistance. So other type of calculation you can perform. The backlink calculation takes a little bit more than the stress strain check. So then when I'll perform it again, I'll just perform that. And here you go. We can go through the different ranges. So there's an overall check that you can have to understand, well, if and how is there's the solicitation of your element. That's why it took a long time. I did it for all the different cases, and then I can have a look, for example, to the equivalent stress of my element. So I can ask either for a stream or just for one combination. Here we go. Then also deformation and mesh of my element. So eventually I can have a look then to how my connection, to the deformation of my connection. So I can go really in detail to check, for example, where I have the compression of the element. So here we can see why and the reason to apply, for example, stiffener. But it will be as well more evident when I'll go through, for example, the backlink check that gives me, in effect, the backlink shapes of my structure and where actually I have my compression. So here I can see that I have this kind of let's say issue to solve. The factor is quite big, so in this case, is not a real problem. But for example, if I check then my welds, my bolts, I can probably have a better implement it better in my calculation and have results that are less important for my two welds. Eventually, you can show also both stresses, either actual forces or shear forces, and you can go then through the Eurocode calculation for either bolts or welds. So is really complete then in the check of your assembly. Once I perform it and it's okay, eventually I can implement also my stiffener. In this case, as I have this issue with my other element, I can actually also say, for example, to set it just upper and then copy it lower, but reduce, for example, the offset, for example, to avoid this clash, let's say. So if I run my calculation, this time just on one element, I just run the stress strain calculation in this case, then I can see there's either my deformation and my compression in the welds are a lot better. So here I can see then I don't have the same kind of issues I had before. I show also the form shape. Here we go. And here I can have a look to a different type of effect deformation. Okay, so this is how you can implement then your connection in StatiCa. Anything you do here, then you can save it. You can just close this window, and for example, if then you change your model, you have other type of, for example, combination you want to export. So I maybe do a design of my connection, then I change an element. The combination are not the same that I want to export. I can just export another type of another time the same connection with another load cases, for example, or another type of section, and it will be updated automatically. So the connection will stay saved, let's say, in SCIA. All the information will be there. Eventually, if you want to work, then if you want to export it out of SCIA and work as, let's say, standalone, you can also do that. There's no problem. Once you have exported your connection, as we can see here, it has been correctly saved with the new type of combination. Eventually, you can go to project and just save as, and you can save it out of your project. So there you go. So this is a little bit the first type of interoperability and a little presentation of IDEA StatiCa. We have just had a look to anyway standard, let's say standard connection that is column beam, but in fact we have studied it in 3D, taking into account also all the effort and all the influences of, for example, ratings or our purlins. So in this case, is a study you can perform either on really complex combinations, connections, or either on also to check a most simple case, but in a really quick way and in a 3D environment. So you can use it both ways. As well, this presentation, this was the presentation a little bit on the steel part. So as you can see, then we have a lot of connection as well. You can export then the effort from for any nodes and eventually then integrate it in the same connection, or either you can select it and eventually copy the attributes to another type of connection. Obviously, it should be in the same side, but if it's in another side, maybe you just need to change the references of the element then to update it. So you can always export it as a model. You can always export it, just copy it, copy paste, and then use it in the same model. I'll go through now the concrete part, and in this case, I'll show just the concrete check. Sorry, there we go. So here I have my concrete elements, and I can study, for example, just one. Here we go. This one. And what I can do in SCIA is, in effect, this one I don't need it as well, is in fact to perform a check on 1D elements and 2D elements. So I'll go through the 1D. I'm just checking. I took the wrong model. Let me see. Here we go. So this is a model I prepared as well for the concrete check. I'll have a look to the same elements anyway. So here I have the different elements. As you can see, you can either work in SCIA with 1D elements, so implement your reinforcement as a rectangular section, or also as a T section. So as here we have as well concrete deck, then we can ask to perform the analysis, in any case integrating also the efforts of the concrete deck, and we will perform the analysis and the design on the T section. So this is something eventually you can do in SCIA Engineer as well. I'll just come back for the last time, promise, to this configuration. The first thing you can check in the concrete design is, in fact, the internal forces for 1D element. So we'll start from there. In the concrete setting, you have the option, in fact, to choose as well to take into account a second order analysis for the column if needed, or eventually to reduce the shear effort above the support, or have a moment that will be also the shift of the moment for as recalculated internal effort. In this case, for example, if I have a look to my combination, for example, in final case, and I'll show you just the moment on my structure, I'll show you either the moment that is coming from the FEM analysis, and the moment instead recalculated from SCIA Engineer based on the assumption I just mentioned. So as you can see, there will be, for example, for the beam, it will take into account the dimension of the column to then cut the shear effort, and then the shift of the moment to then take into account the correct effort. And for what it concerns instead the columns, you'll have the implementation of higher, as you can see here, higher moment due to second order analysis. So it takes into account the imperfection for this kind of element are as it's needed for this check. I'll go through the reinforcement design. So in this case, I'll ask the provided the diameters I need for this kind of elements. In the design default, you can set some basic information that you want the design is based to, and for example, I can edit my design base, I can say, and I can ask, for example, to have in any case a diameter 20 on top and bottom, and eventually, if needed, it can add other phi 20 diameter, so as a 0, 1, 2, 3, 4, 5 rebars. So in this case, this one will be obliged to add them, and the other one it will add it eventually. For the detailing, for example, in this case, in this position or other position for the shear reinforcement, it can use the P10. I can set it here. So this is the first for the T section, and eventually for column, I'll do the same. So I can just ask, for example, to use P20 like mandatory, and then eventually I can ask for additional. I can leave P16 for my calculation. Okay. I can also ask for the calculation of the shear reinforcement. So in this case, I can ask it to perform it by the spacing. So it will analyze my beam and will add different kind of spacing based on the assumption I gave. I run it. So finally, I can run it. My provided my provided rebars that I need in my model. So in this case, it will show me what it needs. So for example, for this column, you need to add additional reinforcement. For this column, instead, no, for example. So it depended on the analysis. And eventually, I can check the difference between the required in square millimeter or the provided. The provided takes into account everything I mentioned before, but also let's say the minimum reinforcement I need to provide. You have as well a quick overview then of the what you need. So a little bit a quick check of your elements. So here I will say, for example, that at the level of details is not okay. So we will have a look at that later. And I can actually ask, for example, then to convert this bar I see in real bars. This kind of rebars, I can export them to some of the design software, detailing software, or the software like I can mention Allplan, Tekla, Revit, SCIA. There are different kind of software I can export it to, or all the software that can read the EFC export, and I can go through then, for example, a calculation of one of these elements. I can run an overall check based, for example, on all the combination. There you go. So I will ask either for capacity design or detail provision and SLS check. In this case, it'll check my element, and it will tell me, okay, there's something that you made it wrong in the assumption you took. This is made on purpose, just to let you know. And here you can have a look to a quick overview of your project. And for example, I can have a look that is the detailing provision that is not correct. All the other checks are quite fine. So I said, okay, I still don't know. I still don't want to change it all or have a look. I want to go through this check really in detail. In this case, you can select the section check. You can go through then the class I said before, and you can perform an analysis on this element. In this case, the actual rebars are taken into account, and here the check is performed. You can actually see all the check made in that section of the element. I didn't took luckily the worst one, but I can have a look, for example, either to implement, for example, here I say, okay, I could implement other type of rebar, so I can have a look directly in live to change this diameter, and a section check, the section check for ULS and SLS will be performed as well. So this is actually a live change that I can make to have a look that all my information are correct. And I can, for example, start from the detailing. Here it's just saying that the spacing of my stirrups is too big, so I can just change it, for example. And now it's correct. And in here you can also have an overview of all the check of that section to go then deeper into that calculation and eventually to find where you need to focus on your end. So this is a little bit an overview, and as well. So at that point, I can just edit my reinforcement as I said, and ask, for example, for along all the bar to have 216 and the spacing of 0.2. So now I know that it should be correct, even if I didn't take the worst case scenario. It should be in any case fine. So I can choose it again, and I can go through the overall check again as I did before for the current element, and it will check all the ULS, SLS, and detailing as well. And at this point, it will be fine. In any case, you have the same capacity response, stress limitation. You can run it as well to their whole structure. So eventually, you can run. I just run for load case for self weight to make it quicker, but you can run it as well on the whole structure to have a look. For example, if your ULS check, your capacity design is good enough, or if you want to go deeper in all the elements through this check. So that was a little bit for 1D. For the 2D, I'll go really quick, and I'll perform an analysis, for example, on the slab. So I select it. Here I can go through the reinforcement. In this case, what I can ask, for example, is as well. I will just perform the ULS calculation. It will be similar to the SLS, and eventually I can ask the provided one. In this case, well, I'll ask it will perform for either the upper surface or the lower surface of my element. So I have all the direction here. The first check is, for example, I have to take into account also my ribs, because I don't want to perform it there. In this case, I can ask, for example, the reinforcement I need on top. In this case, so there's a basic mesh I set in the design default, same as I did for concrete, and an additional mesh that I can provide. In this case, for example, I have then the reinforcement for both direction, upper and lower, for example. If I take, for example, this one, then I can go also deeper in the calculation. I can say, okay, here I need to go through this part. Maybe I want to add myself a reinforcement to then check this part. I can maybe set 14, for example, every 100 as additional rebar that I want to add. I should pick the right direction, but I'll just apply it to my whole mesh, for example. And in this case, I'll add, let's say, my user rebars, my user mesh, or additional rebars, and I can perform again my calculation, taking into account also that it will still take into account the basic mesh I gave before, and it will add this additional rebar. So this is how then you can perform this calculation, and it will show me then that with the additional rebar I added is enough, or I need to add instead of 14, I maybe need to add 16 to make it work. So this is how you can perform as well a ULS check. It's really quick. So we will, in any case, go. We have already been go deeper in some webinar, and eventually we will come back in some trainings or webinar if you are interested as well, to have it more performant than what I show. In any case, what I want to show as well, it was to export this variable beam to then to be analyzed in StatiCa concrete. This is our last topic. And in this case, I can either export the whole concrete structure, the whole structure as well, to perform, for example, other type of analysis of some nodes or some other type of rebar if I want to add them, or I can, for example, just export a part of the structure to show you how it works. In this case, I just export 3 elements. Here I have my B64, B98, B97, and to export it, you can use this XML document. Is like the base of all the data you have in your model of SCIA Engineer. Here you can find then all the information, 1D, 2D element openings, load cases, everything is set here. And what I did was, I need to regenerate it before. Here we go. What I did was to choose some of the elements. In this case, the 3 elements I showed you before from my list of elements in order to export just this element. So I did that just to have the information I wanted to show you today, but eventually, as I said, you can export most of them. In this case, then I can, for example, add. Here we go. I can write SCIA to IDEA, or SCIA IDEA. Great. Here we go. And then I can export all the data from this project to them that then will be imported in my other in the other software. So here's all the information. I'll open, probably it's already open here, IDEA StatiCa. I can go, so to export it, I need to go to the PIM part, and there is why is this? No, it should be. I'll do it. I'll open it again because I'm not sure. Here we go. Better in English. You can import from other program, and in this case, there's the possibility to import from the XML file of the engineer. I'll import my section, and here, as you can see, all my structure has been imported. So every member I selected in this case, and I can actually perform then different type of analysis. In this software, you can actually ask for a, let's say, a section check based on some information on that we're going to add, or some reinforcement that you want to add. And this is another type of software of the main part of concrete. Here you have different parts. In this case, we are in one of these software. So this is the probably got it. Yeah, sorry. This is this is one of these software, and then you can actually ask to, for example, what we want to do is instead to study really in detail the ULS SLS check for only the variable beam. In this case, you have, for example, design group. I want to select my element variable beam. Here I have all the elements, all the combination I have exported. Eventually, the forces in my element, I can show them, and I want to export this type of element for a really focused detail. So I can export it. I can use this button. I can ask to import the whole member. So in this case, I'll just ask the whole member. If I export more parts of my project, I can actually then ask to export just one part, just one portion of this element. And then here it asks for combination. I won't pick all the combination. I'll just pick a couple of ULS and SLS. Here you go, for example. And I'll do finish. So now what I did was to export, in fact, my this beam on this detailing software, and now in here I can have a look to then implement my reinforcement. In this case, I have my geometry. there's a couple of assumptions I need to make. So the first thing is, in fact, that, for example, in here I can add the complete support of this element. So that's quite. I will really go through quick, but it's quite simple then to add another portion, for example. Okay, so for example, I can add. So now my my support is complete, as it was half of the distance. Same thing I'll do on the other side. So let's just. So now my support is complete on both sides. What I need to add is also a bearing plate. So this is just we can add it on the length, for example, of the column, or the or eventually a little bit smaller. So I do 40 centimeter at the beginning of M1, and then I'll add it also at the end. So I just copy it and add it then to M5. And then we add just the support. So in this case, it was a pin support. So I'll add it and I'll link it to the bearing plate. There we go. So the first bearing plate and the second one. After this, we pass through the load. In this case, the only things we need to do is to add the reaction of the support to link them to the support we have just set. So in this case, I will link it to the two bearing plates. Here we go. And we need to do it for every load case. So I'll just do it for the first two, then I have another model already prepared with all the load already assigned. Once we do this, then we can go through the reinforcement. In this case, as well, in the model ready, we will see then all the elements assigned, all the different rebars assigned. Here, I'll show you how to assign, for example, a rebar along the lower surface of the element. So the first one will be following the different surface on the bottom side. So as is a variable beam, I need to use the outline of these members, and then we can work on the length of the bar to then set it correctly. So once we do it, then I'll add just another bar. In that sense, I'll add a bar. For example, this is much easier if you want to add it just on top of the element. I'll add also the anchoring. So in this case, I'll put it on top, and then okay. Then I can add my two anchors. At the moment they are up, but we will see that later they will be following our element. And then I just have to add I just have to ask that this will be from the beginning to the end of the element. So I'll add it on both sides. So now we'll see along the element, and we will see that as soon as I add another element, or I'll go out from this window, the anchor will be on the right side. I add stiffeners. So here you go. This is a little bit the model if I want to treat it like that, and there's already a spacing done. I'll take the other model. This one is the complete one. I add also a couple of holes in the beam. So here you go. The spacing of the stirrups now is already set correctly, and also the different rebars. I'll go then through the check. There's a ULS check here down here. So there's an overview of the whole checks. And then we can go through the stress strain check. So here you go, strength, the check in the concrete. So we see also the arc effect on this element. And then we can go also through the stresses in the rebars. Here you go. So it always shows the maximum value, so I can actually check it. And then we go to the stress check and the crack check. In this case, I already dimensioned it correctly, so there's not really a big problem in this case. And the last one is the deflection, where we can have a look to the total deflection, or for example, here is the immediate deflection. Okay, so this was a little bit an overview of our SCIA to SCIA engineer workflow. There is an offer in this period. That's also the reason for the webinar until the 18th of June. So you can retain that. In any case, our sales team will be in support with you for any information, and we'll contact you soon. If you have any technical queries other than the one I will answer now, you can always ask to our support. In this case, I'll just take all the questions. Okay, so the first one is when you have a lot of combination to check, a lot of memory is used in SCIA, so a lot of time to adjust the model. Is there a solution for that? Yes, there is. You can always in SCIA have a look to. Let me come back. Have a look to the most, let's say, important combination. Typically on for what it concerns the linear calculation, and the combination is quite quick. We have seen it a little bit before. If needed, and if you have really a lot of combination, you can actually go through. For example, I take one cross section. You can go through all the member calculation and eventually ask for combination keys. In this case, you can focus for either all the elements or some of them to those combinations that are the one who dimension your structure. More you ask for detail, if I ask, for example, for all the elements, more you will receive also combination keys. So you can actually have and come back to have a look, for example, to all the combinations that can dimension of your element. In any case, if you have, like with win combination and select combination, you have 1,000 combination, you can reduce this to then a lot less. So for example, it can be, if you have not a lot, it can be 10, just to dimension your structure, and then you can pass to 100 to then perform your complete check. So I hope this had answered. Is the statement of the connection imported into SCIA? It's not direct, but it's, let's say, quite. In fact, you have the result of the steel of the connection thickness, and in SCIA is just let's say a click. In fact, when you select an element, here you go. If I select one element, then you can actually then add your stiffness in here, and is the same unity. So it's just a copy paste on in SCIA Engineer. Eventually, in SCIA Engineer, you can always use table input. So if you need to go through that, you can actually go, in fact, on the hinge and ask, for example, for flexible one, and go through then and copy paste then all the information in the flexible. Here you go, for example, and you can add it here. So just copy paste as if it were an Excel. So another request was just about a trial version. Yes, you can have a trial version for both software. So eventually you can contact the sales department from the address I gave you before to have more information about that. And during your trial version, either for IDEA or SCIA, you can always contact as well our support. So there's no limitation on that. I hope it was good enough. I hope it presented you the both software. Okay, I couldn't go through every detail, but in any case, as I said, we have here. If you try it, then you can always come back to us. There's a lot of material online as well. So this is the end of this webinar, and here you have as well our website for any information.